Okay guys, now we are going to go into part 2, which is reflection and refraction of light wave. Right now, I want you to recall back what we have learned on reflection and refraction. First one being reflection. Okay, if you can still remember, for reflection we have two laws. Before that, I'm going to show you a plane here. Okay, not the plane that flies over the sky, but the plane that I'm referring to is a surface where the light passes through or where the light hits and reflects back. Okay, so let's say this is my plane, alright, and I'm going to draw a normal line here. So what's the purpose of a normal line? Let's recall back. Normal line is a line that is perpendicular to the surface, and the purpose of the normal line is to determine the angle of incident as well as the reflected or refracted angle. So let's say I have an incident ray here. Okay, and the incident ray hits the surface, which reflects back the light. Right, so how do I determine the incident angle and the refracted angle? The incident angle would be between the normal line and the ray, so this will be my theta I, and the refracted angle will be the angle between the normal line towards the reflected ray. Okay, so this will be my theta R. So according to the first law, the incident angle must also be equivalent to the reflected angle. And the second law of reflection states that the incident ray, the refracted ray, as well as the normal line must all lie on the same plane. So that will be the second law of reflection. Right, now, done with reflection, let's go to refraction. Okay, we know that before this, for refraction, we have an equation, a specific equation for us to solve any question related to refraction, which is called the Snell's law. The Snell's law will be n1 sine theta 1 is equivalent to n2 sine theta 2. Right? But do we know how we get this equation? Alright, so I'm going to explain to you one by one on how we obtain this equation. Alright, now look at this example. Alright, now on this picture here, I'm going to explain to you what each point represents. Alright, now we have medium 1 and medium 2. Okay, of course for refraction, we have to have different medium. If not, the refraction won't happen. Right? It is caused by the difference in medium or the difference in index of refraction. Right, so we have medium 1 and medium 2, and we have a ray of light here, okay, which passes from medium 1 into medium 2. Right? And of course, we have to draw a normal line here, okay, for us to determine the incident angle as well as the refracted angle. Right? Now, what are these three lines here? These three lines represent your wavefronts. If you still remember Huygens principle, okay, light wave will create wavefront. Alright, now, so from these wavefronts, alright, we are going to draw it straight towards the interface of medium 1 and medium 2 into the second medium. So from medium 1 into medium 2, there will be point A, okay, which is the interface between medium 1 and medium 2, right? And then we have point B. Okay, so point B will be point B will be the incident ray point. Okay, we have point C, okay, where we have wavefront inside the second medium. Last but not least will be point D, where we have wavefront at the interface, but exactly at the normal line. So why do we need these 4 points? Alright, to create a trigonometry or a triangle. Okay. Now, as usual, if we have trigonometry, it is to solve a certain value where we get from either the angle or from the values at any point. Right. So we will look at these two triangles. Okay. The first triangle will be BAD. The second triangle will be ADC. Sorry about that. Okay, ADC. Right. Now, why these two triangles? Okay, I'll explain one by one first. Okay, I'll show you the first triangle, which is A, B, and D. Right. Now, the first thing that we need to do is find the angle, is to determine which point is the angle taken from. Right? So I'm going to take it from A. Right? YA, because I have this value here. Okay, as well as this value. So where do I get this value from? And why do I need to take AD? Why do I take BD? Alright, now BD is the distance from the first wavefront to the second wavefront. The distance here. So why is it written as V1T? Now let's recall back into part 1 where you have learned that the velocity is equivalent to displacement over time. So displacement 1 over time. So the value that I want here is displacement 1. So displacement 1 is equivalent to velocity 1 times t. So that's how you get V1t here. Okay. And then why do I take AD? Okay. AD is taken because it is the interface between medium 1 and medium 2, also used by ADC triangle. You want the same value, okay, so that we can cancel out any values that are given. Right, so that's done there. So I know I will take this angle here. So let's say this is my first angle. Okay, now let's look at the second triangle or the second trigonometry, which will be point A, D, and C. Again, I am taking the point here because I want the distance, the second distance, as well as the interface. Right, as well as the interface, okay, which is A, D, and C. So I'm going to take point AD here as well as the S2 here. Okay, so from here, let's look at the first triangle. I want to use sine because if let's say I use tangent, okay, it will be front and side here, which I don't have the value and I'm not sharing it with the second triangle. So the best will be sine. So I'm using sine theta 1 is equivalent to S1 or V1t, okay, over AD. So I'm gonna derive this. I will get V1t over AD. So this would be my sine theta 1. Let's look at the second trigonometry, which is sine theta 2 is equivalent to S2 over AD. Again, I'm going to derive this. I will get V2t over AD. Look at these two equations. Which one have the same value? Yes, correct. AD, they share the same value of AD. Right, so how do I cancel that? I can either minus or plus or divide or whatever way for me to cancel out the AD. So I think the best way will be dividing them. Alright, so let's try. Okay, sine theta 1 divided by sine theta 2. So I will get here V1t over AD times AD. Because if you divide, you have to turn it upside down. So times AD over V2t. So I can cancel out my AD. I will get V1 over V2. Where did my t go? Also can be cancelled out. Okay. So simplify the equation. And I'm going to wrap this off. Okay. So I'm going to simplify the equation of sine theta 1 over sine theta 2 equivalent to V1 over V2. Okay, so because I want it to relate it to Snell's law, I cannot use V. So I'm going to try to use another equation that is related to V. If you can still remember, we have the equation of index of refraction, which is N is equals to C over V. And we have the value of V, because it is the same source of light, it will have the same speed. Okay, so I can get the value of N. So my V will be C over N. Right, so substitute it here. So I'll get sine theta 1 over sine theta 2 is equivalent to C over N1 divided by C over N2. Again, I will simplify this equation. We'll get sine theta 1 over sine theta 2 is equivalent to C over N1 times N2 over C. So cancel out the C. Okay. And I will get sine theta 1 over sine theta 2 is equivalent to N2 over N1. So if you simplify this again, you will finally get the Snell's law of refraction. So that's how you get Snell's law of refraction, simply from wave 1, which is related to the Huygens's principle, right?